Hi Olsam, welcome to the Mercury Virtual. Hope you are doing good. Today I am going to continue with your chapter number 3, that is looping. But before this, let's take a quick review what we have covered in the last class. So in this we have covered the if-else statement in the last class. So today I am covering, or I will continue, or I have covered the last topic, that is if-else statement. These are the if-else statement that is used. We have in the last class we have talked about the if-else statement, that is what is the if-else statement, how if-else will be used. If the basic salary is less than 1500, then calculate the HRA as a different, DA as a different, else calculate HRA as a different and the DA as a different. So this is the example that we have discussed in the last class. Then we have discussed about the flow chart, how it will be represented with the help of a flow chart. Then these are the few points that will be used, that is the if-else statement. Then we have discussed about the nested if-else, that is we can use the else condition or the if-else condition within the if condition, that is we can use the if-else under the else condition. These are the different forms of if that can be used or that is used. That is, if statement can take any one of the form. These are the form. This is only single if, that is if the condition is true, perform only or perform any one statement. Next, if the condition is true, then perform the multiple statements. Then if the condition is true, then perform this one, otherwise there is a else, perform this one. Then if the condition is true, perform multiple statement, otherwise perform multiple statement. Next, next form is that nested if, that is condition is true, then in the else part there is a if else part. Next one, there is a if, under the if there is a if else statement. So one is within the else, one is within the if, that is nested if else is used either in if block or either in else block. We can use in anywhere. And then we have discussed about the use of the logical operators, that is how logical operators is used in the C programming. That includes AND, OR, NOT. That is 3 operators are used, one is AND, one is OR and one is NOT. AND is used whenever we have to check whether both the conditions are true or not. And when we use OR, in this we have checked at least one condition. If at least one condition is true, then it's okay, the output is true. So that is the AND, OR and NOT. This is the AND, this is the OR, this is the NOT. This is a symbol for the NOT operator. This is the example that we have discussed. These are the multiple scenarios, these are the multiple examples that is based on given percentage, that is the percentage of the marks, percentage of the students. Then what are the advantages and what are the disadvantages we have discussed about using the if-else condition. Then we discuss about the else if clause. This is the else if clause, that is we can use the else if clause, else if block within the if part. This is the example. Use the 5 subject marks, that is M1, M2, M3, M4, M5. There is a percentage. Calculate the percentage, then use if the percentage greater than 60, print first division, second, third and then fail. Then we also discussed about the another example, that is if the driver is insured only if it is married, and if it is unmarried female, then it is above 25 years of age, and if it is male and unmarried, then it is above 30 years of age. These are the various scenarios in which a driver is insured. These are the various important points that will be used. And then we have discussed about the new example, that is this is the example that I have given to you to study, and if there is any doubt then please ask from me. Then we have used the studied about the NOT operator, that is what is the NOT operator, just reverse of the bit, that is if it is used as a 1 then the output is 0, and if it is 0 then the output is 1, that is the NOT operator. and the or. This is the and the or, and there is a not operator that is used to reverse the bits. If it is 1, it is 0. If it is 0, it is 1. Then we have discussed about the hierarchy. Whenever a new operator will be added, the hierarchy will be changed. So this is the new hierarchy. First of all, there is a logical not. Then there are arithmetic and modulus operator, that is divide, multiply, modulus. Then there is a arithmetic operators, that is plus, minus. Then less than, greater than, less than equals to, greater than equals to. Then next relation operator, that is the double equals to, that is your comparison, and then not equals to. Then ampersand, that is the and, then or, then equals to. So these are the hierarchy that we have discussed in the last class. Then what is the output? These are the word of caution. Then we will discuss about the conditional operator also. What is the conditional operator? That depends on the condition. In this, two symbols are used. One is question mark and one is colon. Prior to the question mark, that is on the left of the question mark, there is a expression 1 that is given. That is, if that expression 1 is true, this is, if it is true, then print this one, that is expression 2. Otherwise it is represented by dot. Otherwise it is expression 3. So two scenarios are used. If this condition is true, then print this one, otherwise print this one. This is the scenario that is used. If x is greater than 5, then print the 3 value, otherwise print the 4 value. Then we have discussed about the summary. That is, what is the summary? What we have discussed in this chapter. And these are the various questions that you have to practice and ask the doubts from me if there is any doubts. Now this is chapter number 3, that is a looping. Now let's start with the today's session, today's class, that is chapter number 3, looping. Now first of all, tell me what is a loop. In simple terms, loop is a iteration. What is iteration? That is a same thing is continued so many times. That is, if the same thing is going on so many times, that is a looping. And there are multiple loops that is available in the C program. For example, if I have to write the table, then the same value will be multiplied by 1, the same value will be multiplied by 2, 3, 4, 5, 6, 7, 8, 9, 10. Means the input is same, but the input is multiplied by the different number, that is from 1 to the 10. That is a looping. That is, the same task is to be executed so many times on a repetitive basis. That is a loop. And in this chapter there are multiple loops like this one, the while loop, the for loop, break, continue, do while loop. So these are the multiple looping that is used in the C language. Now this is the let's start with the looping. The program that we have developed so far used either a sequential or the decision control instruction. That is the program that will be used, that is either we are using the sequential or either we are using the decision control instruction. In the first one, the calculations are carried out in a fixed order. That is, the calculations are done in a fixed order, that is in a sequence, that is one after the another. While in the second, appropriate set of instructions were executing upon the outcome of the condition, that is on the basis of the condition. So one we have studied about in sequence, one we have studied about in decision. These programs were of limited nature, but when executed, they always perform the same series of action in the same way, exactly one. Almost always, if someone is worth doing, it's worth doing more than once. You can probably think of several examples such as eating a good dinner or going for a movie. Programming is the same. We frequently need to perform an action over and over. That is, we need to perform an action again and again often with variation in detail each time. That is, if there is some variation, we can deal with some variation on each time. The mechanism which meets this need is the looping. That is, whenever we have to perform something again and again, then we use the looping. And loops are the subject of this chapter. So this is the main concern, that is the chapter, that is a looping. Now, what is a looping? The versatility of the computer lies in its ability to perform a set of instructions repeatedly. That is the versatile. Whenever we say the computer is versatile, that means it has the ability to perform a set of operations, set of instructions on a repetitive basis. That is a looping. This involves repeating some portion of the program either a specific number of times or until a particular condition is being satisfied. That is, the same instruction, same program will be executed either on the basis of the number of times specified or until a particular condition is being satisfied. Suppose I have given the condition that I is less than 5. Then check the condition, I is less than 5. Then on the basis of the condition it will execute. That is, it will execute for 0, 1, 2, 3, 4. Because I is less than 5, that means from 0 to 4 it will be executed. This repetitive operation is run through a loop control instruction. So first of all, we have studied about the sequential control instruction. Then we have studied about the decision control instruction. Now it is the time to study about the loop control instruction, that is a looping. So now I think concept is clear. Looping means to perform the same task on a repetitive basis, that is a looping. There are three methods by which we can repeat a part of the program. That is, there are three methods by which we can perform the same operations again and again. What are the three methods? That is for, that is while, that is do while. So these are the three statements that is used, or these are the three methods that is used. One is using the while statement, one is using a while, one is using a do while statement. Each of these methods is detailed in the following pages. This is the while loop. This says it is often the case in programming that you want to do something a fixed number of times. That is, you want to perform some operation on a fixed number of times. Perhaps you want to calculate gross salary of 10 different persons, or you want to convert temperature from centigrade to the Fahrenheit for 15 different countries. That is, you have to calculate the salary of the 10 persons individually. That is, the fixed pattern is used, that is, calculate the salary of 10 persons only. The while loop is ideally suited for such cases, that is, when the condition or when the outcome is fixed, or when the condition is fixed, that it must be executed 10 times, it must be executed 15 times. Then only the while loop is very suitable, or while loop is suitable. Let us look at a simple example. Which uses a while loop. This is the flow chart that uses the while loop. First of all, there is a start, then count equals to 1. That is, take the variable as the count equals to 1, then check the condition that if the count is less than equals to 3. That is, if the count is less than equals to 3, if it is true, then input PNNR. That is, if the condition is true, then only print or input the PNNR from the user. If it is not true, simply stop the program. Then in next, calculate the SI, that is a simple interest, that is P into N into R divided by 100. That is calculation of the simple interest. So this is a scenario in which we have specified the condition that if it is 0, 1, 2, 3, that is, first of all, no, not 0. Why? Because we have initialized the count with 1. So it starts with 1, it calculates for 3 times, 1, 2 and 3. Because the condition is that if count is less than or equals to 3, so it starts with the 1, then 2, then 3. If it is true, then input the values, input the PNR from the user. Then in next line it is SI, that is simple interest, equals to P into N into R divided by 100. Then print the SI. That is, first of all calculates the SI, that is the processing part, then prints the SI, then at last count equals to count plus 1. That is, every time a loop will execute, at every time count will be incremented. First of all count will be 1, then count will be 2, then count will be 3. So it will be used for the increment. So count equals to count plus 1. So these are the conditions that is used. And this is the example of calculation of simple interest for 3 sets of P, N and R. That is calculation of the simple interest for 3 sets of or 3 numbers of P, N and R. Uses the main function. First of all, use the main function, that is starting with the main function. Then declare the variable. What are the variables? One is P, one is N, one is count. Then uses the float, that uses the float number, that is the 2 variables are of float type, that is R and the SI. So one is P, N and count, one is R and the SI. Then uses count equals to 1. That is initialize the count with the 1. Then use or check the condition while count is less than equals to 3. Checks the condition whether the count or condition is that executes the loop until count is less than equals to 3. That is less than equals to 3. And then if it is less than equals to 3, that is it is 1, 2, 3, then print or enter the values of P, N and R. That is take the values from the user. That is, what are the values? By taking the principal, by taking the number of years, and by taking the rate of interest. That is a P, N and R. Then it must be stored in the memory by using the scanf. So this scanf will be used. 2 are of integer type, but the R is of float type. This is a float type, so use the specify %f. Then P and R. These are the 3 variables that will be used. Then calculate the SI. This is the SI, that is P into N into R divided by 100. That is, principal is multiplied by number of years, that will be multiplied by rate of interest, that whole divided by the 100. Then print the SI, that is a print the simple interest. Then at the end there is a count equals to count plus 1. That is, every time at every loop it will be incremented. That is, count equals to count plus 1. Then curly braces will be closed. So this is the while block. The curly braces will be start and then curly braces will be stopped only for this part. Right. This is the main function. Curly braces will be start, and for the main this will be closed, and for the while this will be open, this will be closed. So it's very important to do the indentation. This is indentation. That this is a while loop. This not start from here only, not at the this one at this stage. No, it will start by giving some margins. Whenever we give some margins on the left side or the right side, that is known as the indentation. This is also indentation, indentation, indentation. This is also indentation. Then curly braces will be opened at the same margin, it will be closed at the same margin, and at last this curly brace will be closed at the same margin. This is known as indentation. That is, proper indentation is used for the program. These are the few simple runs that is used. That is, first of all, enter the values of P and then R. That is, enter the values of P and then R, that is principal, number of years and the rate. That is taking the values from the user, that is principal and the number of years and the rate of interest. That is for example 1005 13.5. Then the simple interest is 675.000. Then in the next one, this is only for the when the count equals to 1. Then next, when the count equals to 2, for example 2005 13.5, this is the output. How this will be calculated? By multiplying these 3 values P and R, then divided by 100. Then in the third run, this is also calculated, that is the 3500, 5, 3.5. So P and R and the simple interest is 612.5. That is, three values are multiplied by each other and then divided by 100. This program executes all statement after the while 3 times. That is, it is used for the 3 times. Why 3 times? First of all, count equals to 1, then count equals to 2, then count equals to 3. So it will be calculated 3 times. The logic for calculating the simple interest is written within a pair of braces immediately after the while keyword. That is, it is used after the while keyword. This statement forms what is known as the body of the while loop. That is, if I say body of the while loop, that is what comes under the while loop or what comes under the braces of the while, that is comes under or cover the under the while loop. So this program will execute 3 times 1, 2 and the 3. This statement forms what is known as the body of the for loop. The parenthesis after the while contains a condition. So long as this condition remains true, all statements within the body of the while loop gets executed repeatedly. So this is known as looping. Why? When that this means these conditions. What are these instructions? These are the instructions. These are executed multiple times. How multiple times? When the count is 1, when the count is 2 and when the count is 3. So it will be executed 3 times. To begin with, the variable count is initialized to 0, 1. That is, it is initialized to 1, and every time the simple interest logic is executed, the value of count is incremented by 1. So every time it will be incremented by 1. The variable count is many a times called known as the loop counter or the index variable. That is the count. Whenever we use the count variable for incrementing the values, that is known as the loop counter or the index variable. So whenever we use the flag, whenever we use the count, that is known as the loop counter or the index variable. The operation of the while loop, that is the operation that is used in the while loop, is as follows. This is, first of all, there is a start value, then there is a initialize value, then there is a test. That is, first of all, there is a starting point, that is the start the program, then initialization, that is initialization of the variable, for example P and then R. Then test the condition. What is the condition? If the count is less than or equals to 3, that is the condition. Then if it is true, that is condition is true, then only the body of the loop will execute, otherwise it will not execute. Then if the body of the loop execute, then every time it will be incremented, that is a increment. These are the tips and the traps that will be used for the while loop. The general form of while loop is as shown below. This is the general form. First of all, there is a initialize loop counter. That is, this is the initialize loop counter, count equals to 1. And then while test loop counter using a condition. That is, use the test loop, that is check the condition. So in simple terms, first of all, the loop counter, that is count equals to 1, count equals to 2 will be given. Then use the while loop, that is check the condition. Then uses the curly brace, performs the operation, that is do this and this, increment the loop counter. Then closes the braces. So first of all, uses the initialization, then uses the while, then uses the multiple statement, and then in the third line it will increment the loop counter, that is incrementing the loop counter by 1, that is count equals to count plus 1. Note that the following points about loop, that is what are the few points that is available or the important point that is available about the while loop. The first point says the statements within the loop or while loop would keep on getting executed till the condition being tested remain true. This says the statement is executed multiple times. How many multiple times? Till the condition remains true. This is the statement about the while loop will keep on going executed till the condition being tested becomes true. That is, it is going to be tested, it is going to be executed until the condition is false. When the condition becomes false, the control passes to the first statement that follows the body of the while loop. In place of the condition, there could be any other valid expression. So we can use any valid expression also instead of the condition. So long as the expression evaluates to a non-zero value, the statement within the loop would get executed. That is, whenever we use a non-zero value, that is either 1 value, then the statement within the loop, the statement what is called within the loop would get executed. Next point says, the condition being tested may use relational or logical operators. That is, the condition that is used or that is tested may use the relational operator or either logical operator. What are the relational operators? Like I told you, relational operators are that is used for the relationship, that is less than, greater than, less than, equals to, greater than, equals to. And logical operators include and, or, and not. This is the example. One is simply the relational operator. This is also a relational operator. Then this is a relational operator as well as the logical operator, and the not are used. Next point says, the statements within the loop may be single line or a block of statement. That is, the statement that is used may be of single line or may be of multiple lines. In the first case, the parentheses are optional. That is, the parentheses are optional. We may use or we may not use. For example, this one. While I is less than equals to 10, I equals to I plus 1. This is same as this one. That is, in this, the parentheses are not used, and in this, the parentheses are used. As a rule, the while must test a condition that will eventually become false. Otherwise, the loop will be executed forever indefinitely. And this is when the I equals to 1. When while I is less than equals to 10, then printf I. This means first of all initialize the variable as a 1, that is I equals to 1, that is I has a value 1. Then it check for a condition till 10, that is starting from the 1 until ending of the 10, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then print the value, that is every time it prints the values, and it prints the value in the next line. How it will print in the next line? Because it is using the /n. /n means moving to the next line. So it starts with the 1, then 2, then 3, then 4, 5, 6, 7, 8, 9, 10. Then when it goes to the 11, if this is 11, this is not true. Why this is not true? Because 11 is not less than or equal to 10. This is not true condition, then this will not be executed. This is an indefinite loop since I remains equals to 1. This is I is equal to 1, this remains equals to 1. Forever. The correct form would be addend. This is the correct form. In this, there is no increment of the I. Yeah, this is most important point. There is no increment of the I, that the I becomes 1 every time. So this is the next scenario, that is int I equals to 1, while I is less than equals to 10, prints the value of I, then I will be incremented. One time 1, then 2, then 3, then 4. So how this code will not execute? Because I will not be incremented by 1. That is the main scenario. Every time it is 1, every time it check for a condition for 1. That is an indefinite loop, that is it will go on executing. This will not end. That is known as indefinite loop. Indefinite means that will not end, because there is no condition that will be ending, that is a false condition, because I will not be incremented. So every time it checks for the 1. This is the correct form. I equals to 1, I is less than equals to 10, then print the value of I, then I will be incremented. Instead of incremented a loop counter, That is, instead of incremented any loop counter, that is I equals to I plus 1, we can even decrement it and still manage to get the body of the loop executed repeatedly. That is, it is still manageable, or we can also decrement the value of the if, that is shown in the given program. First of all, uses the main function, then uses int I equals to 5. That is, 5 is initialized to the I, then I is greater than equals to 1. Checks the condition until 5 is greater than equals to 1. Now this is a different scenario. In first part, we have taken I as a small value, that is 1, and then continue till 5 or 10. In this, we have taken I as a big value or a large value, that is 5, then reverse the condition, reverse the expression. That is, first of all it is less than, now it is greater than. So this is true if this is greater than equals to 1. 5 is greater than equals to 1, yeah, condition is true, print the output. In the next line, that I will be decremented. Now I become 4, check the condition. 4 is greater than equals to 1, yeah, greater than 1. Then again the statement will be printed. Then again I will be decremented. Now I become 3, again check the condition. 3 is greater than 1, then prints the output. Again decrements the value, that is 2. Then check the condition, that is 2 is greater than 1. That is, if the 2 is greater than 1, then again prints the value or prints the statement. Then again decrement the value, that is 2 minus 1, 1. This is also true, that is 1 is greater than equals to 1, yeah, 1 is equals to 1. Again prints the same line. Then again it will decrement. Now I become 0. This is satisfied. 0 is greater than 1. No, this will not satisfy. Then it will be stopped. So it will execute for the 5 times. 5, 4, 3, 2, 1. So now this is the scenario, that is, we can also decrement the loop counter. So these are the multiple scenarios in which it shows how we will decrement the loop counter, how we will increment the loop counter. It is not necessary that a loop counter must only be an integer. It can be a float also. This is float a equals to 10.0. And then check the condition for the float also. That is, a is less than equals to 10.5. If the condition is true, printf this one and printf this one. Then increment the value of a to the 0.1. Even floating point can also be decremented. If I use the floating point, that can also be decremented. These are the multiple examples. This is an indefinite loop. Why it does not give any output? Why? What is the main problem? You tell me. The main reason is that it is carelessly used as a semicolon. That is, use the semicolon after the condition. That is not possible. So this is the mandatory condition, that no semicolon will be used whenever we check any condition, whenever we use any loop. That is, it will not be there, or the semicolon is not there after the condition, after the looping. Then uses the printf, prints the value I, then increments the value by 1. That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Since the value of I is not been incremented, the control will keep on rotating of the loop externally. Why externally? Because semicolon is used. Note that the printf and the I equals to I1 within the pair of braces is not an error. In fact, we can put the pair of braces around any individual statement without affecting the execution of the program. Now, what are the operators that is used while using the while loop? That is, what are the operator, logical operator or relational operator that will be used whenever we use the while loop? This says there are a variety of operators which are frequently used with the while loop. To illustrate their usage, let us consider the problem wherein The numbers from 1 to 10 can be printed on the screen. The program or the program for performing this task can be written using while in the following different ways. That is, we can use the while loop in the following different ways. Uses a variable, that is main, then int I equals to 1, that is initializing the value of I to the 1. Then uses I is less than equals to 10, that is start with the 1, it will execute till 10. So first of all it will be 1, then 2, then 3, 4, 5, 6, 7, 8, 9, 10. Then it will be incremented by 1. So every time it will execute 1 by 1. We can either use I equals to I plus 1, or we can also use I plus plus. Both have a same meaning. So the loop counter is also incremented by using the plus plus, or using I equals to I plus 1. That is an increment operator. Every time the statement I plus plus gets executed. Similarly, to reduce the value by 1, we can use the decrement operator, that is minus minus. So either we can use plus plus, or either we can use minus minus. However, never use n plus plus plus. That is 3 times plus is not used for the increment. That is used by only 2. Since C does not recognize the operator that is plus plus plus. Next, this is also a scenario. We can also use the loop counter as this one, I plus equals to 1. So we can use either I equals to I plus 1, I plus plus, or I plus equals to 1. This is a compound assignment operator. If it increments the I by 1, similarly j equals to j plus 10 can be also written as j plus equals to 10. This j equals to j plus 10 is also represented by or written as the j plus equals to 10. Other compound assignment operator that will be used are equals to, multiplied equals to, slash equal to, and percentage equals to. So these are the multiple operator that can also be used, that is the assignment, compound assignment operators. Then this is the next example. Int I equals to 0, I plus plus is less than 10. That is, first of all increment the value at the same time and then check the condition. That is, incrementing is also done at the looping stage, that is at the loop state. But it's my advice that do not use this one, because this is very confusing part. Always use the increment or the loop counter at the end of the program. This says in the statement, while I plus plus is less than 10, firstly the comparison of value I with 10 is performed, then the increment of I takes place. Since the increment of I happens after its usage, then the I plus plus operator is known as post increment operator. When the control reaches printf, I has already been incremented, hence I must be initialized to 0. This says this loop also works, but it's not advisable to use this one. Why? Because it is very confusing whether increment the value first or whether check the condition first. So use the simple variable, check the condition, and then at the end of the loop, at the end of the while block, we can use the loop counter that is used for the incrementing or decrementing. Now next is your for loop. So till now we have covered about the while loop. Now next part is your for loop, that is the next loop that will be used. So one is while, one is for, one is do while. So this is the next loop that is used, that is the for loop. This says perhaps one reason why few programmers use while is that they are too busy using the for loop. That is, they are too busy by using the for loop, which is probably the most important looping instruction. Yes, this is one of the most important as well as one of the most popular looping instruction. This is most commonly used loop, for loop, by most of the advanced programmer as well as by most of the beginner programmer also. The for loop allows us to specify three things about in a loop in a single line. So as you see in the while loop, there are blocks of statement in the multiple lines, agree, but the for loop is used only in a single line. That is, in a for loop we can give the statement, we can check the condition, all that what we check or what we initialize, all in the single line only. What are the things that we use in a single line? Setting a loop counter, that is, use the count equals to 1, flag equals to 1, I equals to 1 to an initial value, that is I equals to 1, count equals to 1. Then test the loop counter. Test the loop counter means test the condition while I is less than 10. In the same way we use in the for loop, I is less than 10, to determine whether its value has reached the number of repetition desired. That is, whether the value that is used reaches the number of repetition that is desired or that is required. Then next third part is that increasing the value of loop counter each time the program segment within the loop has been executed. That is, every time it will increment the loop, that is the next part, that is the third part. So three part is used. One is the initialization, that is at the initial stage, then testing the condition, that is condition, then increment the value or decrement the value. So these are the three syntax, or these are the three parts of the for loop. One is initialization, one is testing, one is incrementing or decremented. This is the general form for the for statement. This is the general form that is used. First of all, there is a initialize counter, that is a initialization. For example, I equals to 1, that is a initialization. Then there is a test counter, there is a test condition, that is a test counter. For example, I is less than 10, then increment the counter or decrement the counter, like I plus plus, I minus minus, count minus minus. So these are the three parts of the for loop. One is initialization, one is condition, one is increment or decrement. And then there is a curly braces, and there are multiple statements like do this and this and this. Let us write down the simple interest program for using for loop. That is, the same example will be repetitive. That is the calculating the simple interest, that is P into N into R divided by 100. So this now simple interest will be calculated using the for loop. Compare this program with the one which we wrote using the while loop. The flowchart is also given for a better understanding. This is the flowchart that will be used. First of all, there is a start, then initialize the variable as a 1, that is count equals to 1. Then uses count equals to count plus 1. That is, uses the variable or uses or increment the values of count, that is count equals to count plus 1. Then checks the condition, that is checks the condition is count is less than equals to 3. That is, if the count is less than equals to 3, so it start with the 1, it end with the 3. Then if it is yes, then inputs the values P, N and R, calculate simple interest, that is P N R divided by 100, then print the SI. If it is not true, that condition is true or not true, then no, it's not okay, then stop the values. This is the calculation of simple interest for 3 sets of P, N and R. Now starting with the main function, that is the main part. This is an example for calculating the simple interest by using the for loop. So first of all uses the int variable, that is P and count. That is, three variables are used. One is p, one is n, and one is count. Then uses the float variable. What it uses the float variable, that is r and the si. That is the rate of the interest and the simple interest. So three variables are of integer type and two variables are of float type. That is a real type. Then uses the for loop. That is use the for loop for calculating the si. First of all, uses the count equals to 1. That is, first of all, use the count equals to 1. That is initialization of the count variable. That is a loop counter. That is count equals to 1. Then checks the condition that count is less than equals to 3. That checks the condition either count is less than equals to 3 or not. So it will execute till count is less than or till count is equals to 3 or less than 3. It will not execute for the 4. Then increment the value by using either count plus equals to 1 or count equals to count plus 1. Then print the value, that is enter the value from the user, that is enter the value of p and r. So it takes the input from the user, then scans the value, that is scan the value by using the specifier, by using the identifier, that is ddf. So one is %d, one is %t, one is %f. Why they are using two d's? Because p and n are of integer type and the r is of float type. Then uses the si, that is si equals to p into n into r divided by 100. Then prints the value of or print the value of si. So this is the scenario, this is the syntax that is used. That is si. Then curly braces will be closed and then this curly braces will be closed. This is the for loop. First of all, there are three parts. First of all, initialization, that is count equals to 1, then condition, then count equals to count plus 1. And these are the multiple statements that will be covered under the for loop. So this is the for block, from this to this one. This is the for block. If a program is compared with the one that is written using while, it can be seen that the three steps, one is initialization, one is testing, one is incrementation, that is in the 3 lines, initialization, condition, testing, and the increment required for the loop construct has now been incorporated in the for statement. Let us now examine how the for get executed, that how for will be executed. That is, when the for statement is executed for the first time, that is when we use the for loop for the first time, the value of count is initialized to a 1, that is count equals to 1. Now the condition is count is less than 3, that is count is 1, that is satisfied, then the loop will execute. Upon reaching the closing braces of 4, that is when we reach on the closing braces of 4, control is sent back to the for statement where the value of count get incremented by 1. Again the test is performed, it exists till 3, that is it says first of all count 1, check the condition, condition is true, the body will execute. Then count equals to count plus 1, that is the count value will be incremented. Then again check the condition, 2 is less than equals to 3, condition is true. Then executes the body of the loop, then increment the value, that count is equals to 3. Again the test is performed to check whether the new value of count exceeds 3. If the value of the count is still within the range of 1 to 3, the statement within the braces for loop or 4 are executed again. The body of the for loop continues to get executed till count does not exceed the final value 3. When the count reaches the value 4, that is when the count reaches to the value 4, the control automatically exits from the loop and the control is transferred immediately of the for loop. That is, if the condition is false, then the control will be passed to this one, that is the closing braces of the for loop. The following figure will help in further clarifying the concept of execution of for loop. This is the condition, this is the flow chart. First of all, there is a start, then there is a initialization, that is there is a start value, then there is a initialization, that is initialize the variable, then check the condition, that is testing part. If it is true, then executes the body of the loop, increment the value at the end. If it is false, then stop the value. It is important to note that the initialization, testing and incrementation of a for loop can be replaced by any valid expression. Therefore, the for loop are perfectly okay. These are the for loop that is perfectly okay. That is I equals to 10, I minus minus 4, j, 5, j plus. These are the multiple loop conditions that will be used. Now let us now write down the program to print the numbers from 1 to 10 in different ways. This time we will use a for loop instead of the while loop. That is, this time it is using the for loop instead of the while loop to print the number from 1 to 10. This is the example that is used for the using the for loop for printing the values from 1 to 10. That is, first of all uses the variable that is of integer type int I. Then uses for loop, that is first of all initialize the variable by 1. Then check the condition, that is I is less than equals to 10. Then uses I equals to I plus 1, that is incrementing the values, that is I equals to I plus 1. Then uses the printf that is used for the printing the values. So first of all it is 1, then check the condition till it will become 10, then I equals to I plus 1. Note that the initialization, testing and incrementation is done in the for statement itself. Instead of using this one, we can also use this or this one, as I told you earlier. This is also used in this int I equals to 1. So this is the scenario. This is the third place, that is I equals to I plus 1 can be used at this one. This says, note that in spite of this, the semicolon after the condition is necessary. So this is very necessary. Next part, this is necessary, that is it will be used not in this way, not at this place, but in the place of the upper side, that is int I equals to 1. So these are the multiple scenario, but the main scenario is it's mandatory to use the semicolon whether the statement is given or not. This is next one. This is also next one, that is both the initialization and the increment is done separately and the condition is done separately. This is also used I plus 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 I. Now next is your nesting of loops, that is how for and the while loop can be nested, that is used within the for loop can be used within the while loop. So how one loop will be executed within the another loop, that is a nested of the loop. But before this, let's take a quick break or 5 to 10 minutes break, then come back starting with this topic, that is nesting of loops. So first of all, let's take a break. Come back from the break. Next, let's start with the next topic, that is nesting of the loops. That is how nesting of the loops will be used. That is how we can use the while within the while, for within the for. That is the nesting of the loop. So let's start with the nesting of loops. This is the way if statements can be nested. In the same way the while and for will be nested. To understand how nested loop works, look at the following programs that is given below. So look up this program, that is a nested loop. First of all, uses the main condition, main statement or the main function, that uses the main function. These are the three variables that will be declared. One is R, one is C, one is sum. So these are the three variables that will be used, that is declared of integer type. Then uses the for loop, uses one for loop, that is R equals to 1, that is initializing the variable or initializing the variable by 1. Then checks the condition. What is the condition? That condition is R is less than equals to 3. This is the condition. Then increment the value, that is R plus plus, that is the outer loop. Then in the for loop, again for loop is used. So one is known as the outer loop, one is known as the inner loop. So one is outer, one is inner. Then uses another variable, that is C, that is C equals to 1. C is less than equals to 2, C plus plus. So first of all R 1, then check the condition till 3, that is 1, 2, 3. Then in the inner loop there is a C, that is 1. Then check the condition of the 1 and the 2 and C++. So one loop is used under the another loop. One is known as outer loop, another one is known as inner loop. Then inner loop, in the inner loop we can use the variable that is sum, that is combining or that is used for adding the values of R and C. That is the R value and the C value is added up, or the addition is performed on the R and C, and the output is stored in the sum variable. Then prints the value of R, C as well as the sum. Now this is the syntax. As I told you, whatever we give in the printf in the double quotes, that will be printed as it is, that is the exactly. So it is printed as R equals to, that is R equals to percentage D, this is the percentage D, and C equals to percentage D. Why they are using percentage D? Because this is R and C are of, and both are of, all the three are of integer type. So in the sum also it is using percentage D. So it is also percentage D, percentage D, percentage D. So this is R equals to percentage D, C equals to percentage D, sum equals to percentage D. So these are using R, C and sum. So one is R, one is C, one is sum. So print the values of all the variables, that is R, C and the sum. One main condition is that until the for or the inner loop will execute, the outer loop will not be executed. That is, until the inner loop will not execute, will not finishes the execution, the outer loop will not execute. So this is the main condition, that is the outer and the inner loop. So first of all, this statement will execute, that is the inner loop, then only the next statement, that is the outer loop, will execute. So first of all, outer loop and inner loop. So this is the outer loop and this is the inner loop. Now let's see the quick dry run. What is the dry run? Whenever we see that when R equals to 1, R is less than equals to 3, that is when we check any condition, or when we check the output, that is known as the dry run of the program. DRY, dry, RUN, run, dry run of the program. So uses R equals to 1, R is less than equals to 3, R plus plus. C equals to 1, C is less than 2, C plus plus. So first of all, check the condition. 1, that is 1. 1 is less than equals to 3. Yeah, it is less than 3. Then R plus plus. Means if the condition is true, go to the inner loop. Only R is 1. Go to the inner loop. Now C equals to 1. Check the condition. C is less than equals to 2. Yeah, condition is again true. Why? Because 1 is less than equals to 2. Now uses R plus C. What is the value of R? 1. What is the value of C right now? 1. So the output is 2. Then prints the value R equals to 1, C equals to 1, sum equals to 2. Now only use the inner loop. Don't go to the outer loop until inner loop will not finish. That is, until the condition of the inner loop will not false, then do not go to the outer loop. So again uses the inner loop. Now see, R is again the same 1, because don't go to the outer loop. Now C becomes 2. Why 2? C plus plus. Next time when it will execute, the cursor will follow here, over here. This cursor will jump to the this one part, that is jump to the this one. Then now C becomes 2. Why C plus plus? This is the condition, that is 2 is less than equals to 2. Yeah, condition is true. Why true? Because 2 is equals to true. Now sum equals to R plus C. Now sum has a R has a value same 1, but the C has a value 2. So the sum is 3. So this is R, this is C. The R value is 1, C is equal to 2, the sum is 3. So these are the outcomes of the two variables, or the two iterations. Now again go to the inner loop. Now C becomes 3. 3 is less than equals to 2. No, condition is false. Now the loop goes to the outer loop. That is, the loop transfers to the outer loop. Now it will go to this one. Here R becomes true. Why R becomes true? Because R plus plus. It becomes 2. 2 is less than equals to 3. Condition is true. Then go to the inner loop. Go to the this one loop, that is the inner loop. Now C becomes 1, or C is 1. Why? Because it is a new loop that will be executed. Sum is 3. Then in the next loop, the again C equals to 2 and the R equals to 2. The sum is 4. in the next iteration r equals to 3, that is this will not executed. Why? Because now c becomes 3, then it will go to the outer loop. When it go to the outer loop, r becomes 3. When it is 3, then go to the inner loop, condition is true, c equals to 1 first time, then sum equals to 4, and in the next iteration r equals to 3, c equals to 2, and the sum is equals to 5. Again go to the outer loop, r become 4, condition is false, the loop will not terminate. These are the scenarios, these are the output. So this is the way how inner loop and the outer loop will execute. That is, whenever we execute the inner loop, until the inner loop will not false, the outer loop will not execute. So first of all, the inner loop will execute, then only the outer loop will execute. Here, for value of r, the inner loop is cycled through twice. That is, for each value of r, the inner loop will terminate or will execute twice with the variable c taking values from 1 to 2. That is, c takes only 2 values, that is either 1 or 2. So it will execute only for the 2 iterations, that is either 1, that is either 2. The inner loop terminates when the value of c exceeds the 3. That is, the value of c becomes 3, it will terminate. As well as the outer loop will terminate when the value of r exceeds 3. So 1 is 2, 1 is 3. So inner loop termination value is 2 and the outer loop termination value is 3. As you can see, the body of the outer for loop is indented. This is the indentation. This is the indentation, this is the for loop, and after some space there is the inner for loop. These multiple indentation makes the program easier to understand. Instead of using two statements, one to calculate sum and another to print it, we can compact this into a single statement. This is used only for a single statement, that is also using the count or also using the sum. This is the sum that is used, r plus c. Means either you can use the different variable that is sum, then print the sum, or either you can use in the same line, that is r plus c, in the for loop only. Then next line says, the way for loop have been nested here, similarly two while loops can also be nested. That is, while loop it can also be nested just like the for loop. Not only this, a for loop can occur within the while loop or a while within the for loop. That is, we can place any loop within another loop. Now, multiple initialization of the for loop. Now, how multiple initialization can be takes place for the for loop. This says the initialization expression of the for loop can contain more than one statement separated by the commas. That is, initialization can contain more than one statement. That is, I equals to 1, j equals to 2. That is more than one statement. This is the condition. What is the condition? J is less than 10 and the j plus plus. This says multiple statements can also be used in the incrementation expression of the for loop. That is, you can increment or decrement two or more variables at the same time. However, only one expression is allowed in the text expression. This expression may contain several conditions linked together using the logical operator. That is, only one condition is allowed, but that condition is also combined with the use of the logical operators. Whenever we use the multiple statements in the initialization, also demonstrate why semicolon are used to separate the three expressions in the for loop. These are the three expressions that is used. One is I equals to 1, j equals to 2, j is less than 10. If the commas have been used, they could not have also been used to separate the multiple statement in the initialization statement without confusing the compiler. Next is your odd loop. What is an odd loop? The loop that we have used so far executed the statements within them a finite number of times. That is, till now we have covered multiple statement that covers or that executes within a or that executes on a finite number of times. However, in real life problems or programming, one comes across a condition when it is not known beforehand how many times the statement in the loop are to be executed. This condition or this situation can be programmed as shown below. This is the old loop. Example of a loop for a unknown number of times. There is no criteria, there is no standard that loop will terminate at what condition. That is, there is no controlling part, there is no termination part. This is only execution of a loop on an unknown number of times. Now, let's take a example or the program. First of all, uses the main function. This is the main function. Then declare the variable. One is of char type, that is another is a char type. Num is of integer type. So one is a char variable, that is another. One is of integer variable, that is a num. Then perform the operations, that is do. First of all, uses the do. Then first of all uses the do, then print the value, that is print the output, that is enter a number, that is it print on the screen, that is enter a number. Then scan the, that is store in the memory in the form of a variable name, that is a num. Then printf square of %d, that is uses the same whatever it written in the double quotes, it will be written as it is. So square of %d is %d. Then print the value of num, that is num into num, it is one expression, this is num. Then next want to enter another number, that is want to enter another number. If it is yes, then uses the another number. This is while, this is a condition. Condition is tested at the end of the loop, that is another equals to y, another value is y. That is, if the another value is y, then it executes the statement, otherwise it will not execute the statement. And here is a simple or sample output. This is a sample output. Enter a number 5, square root of 5 is 25. So this is a number. First of all, enter a number, that is 5. Then find the square root, that is the square root of 5 or square of 5 is 25. Want to enter another number, if it is say yes, this is the example, say yes, enter a number, square of another number is 49. Again it will ask want to enter another number, if it is no, then it will terminate, otherwise it will not terminate. This says in this program the do while loop would keep getting executed till the user continued to answer y. This is till the user answer the output or the input as a y, then it will go on executing next and next and next. That is it will answer the y, that is a yes. The moment he answers n, that is moment he answers n, the loop terminates since the condition, that is another equals to y, fails. So this is the condition, that this is the condition, that if it is true, then only the output is or the loop will execute, otherwise the loop will terminate. So here when the user gives the input as a n, the loop will terminate, that is fails. Note that this loop ensures that statements within it are executed at least once, even if n is supplied first time itself. Though it is simple to or simpler to program such a requirement using a do while loop, the same functionality, if required, can also be accomplished using the for loop and the while loop. Then old loop using a for loop. This is the old loop, that is the do while loop using a for loop on the while loop. Now next part is your break statement. This is the next part. This is or the break statement is used whenever we have to pass the control to the first statement after the loop. Then we use the break statement. This says we often come conditions where we want to jump out of the loop instantly. That is, at the same time we have to jump from the loop without waiting to get back to the conditional statement. The keyword break allows us to do this. That is, the keyword that is used is the break, B-R-E-K. When the loop is encountered inside any loop, that is when the break is used, encountered or used inside any loop, control automatically passes. That is, the control automatically pass to the first statement after the loop. That is, whenever we use the break, then the control passes to the first statement. Suppose we use the break or the curly braces before the break, then the control automatically pass to the first statement. A break is usually associated with an if. As an example, let's consider the following example. Write a program to determine whether a number is prime or not. A prime number is one which is divisible by only one or itself. This is the condition that is used. This is the first of all main function is used. Then uses num and the I are the two variables. Then this is a number, that is print the input, that is enter a number. Then uses the scanf, that is %d ampersand num. Then checks the condition, that is I equals to 2, that is check or initialize the variable as a 2, that is a 2. Now checks the condition while I is less than equals to num minus 1. This will execute till num is num minus 1, that is the number that is given, that is less than 1 or minus 1. Then checks the condition, that is if the num modulus I, that is if the number is divided by I, if it is equals to 0, then printf not a prime number. Break. Whenever we use the break, it will pass the cursor, it will pass the or it will transfer the cursor execution to the first statement, that is this one. In this program, num turns to be a 0 is exactly divisible by I, the message not a prime number. That is when the number is not divisible by I, that is a not a prime number is printed, and the control breaks out of the while loop. The keyword break breaks the control only from the while in which it is placed. This is the it is already placed within this loop. So this will move the cursor to the this block only to the this block. Then next is your continue statement. So these are the two statements. One is break, that moves the cursor or that brings the cursor automatically to the first line. Then next is your continue. This says in some programming we want to take the control to the beginning of the loop by passing the statements inside the loop. That is we take the control to the beginning of the loop only, which have not been executed. That is, we have to bypass or we have to go to all the statements or go through all the statements which had not been executed. The keyword continue allows to do this. That is, we have to go through all the statements that will be done using the continue statement. When continue is encountered inside any loop, that is when the continue is used and inside any loop, control automatically passes to the beginning of the loop. That is, control automatically pass to the beginning of the loop, that is the starting of the loop. A continue is usually associated with an if, that is it is generally used with an if statement. As an example, let's take the following example. This is the example. Uses for variable using the for loop, that is for I equals to 1, I is less than equals to 2. So it starts with the 1, it ending with the 1 and the 2, that is 1 and 2. Two time it will iterate. Then uses the inner loop, uses the j equals to 1, j is less than equals to 2, j minus j plus plus. Then checks the condition if I equals to j, that is if I is equals to j, that is first of all it is 1, j is also 1. Then checks the condition if 1 is equals to 1, that is if the 1 is equals to 1, then continue, that is move to the next statement and prints the value of I and the j, that is 1 and 1. This is the 1, this is the 2. Then again go to this one, then the I become 2 and the j become 1. So this is the output. Note that when the value of I equals that of j, the continuous statement takes the control of the for loop to the for loop by passing rest of the statement pending execution in the for loop. That is the inner part. Now, next loop is your do while loop. That is the last loop of this topic. That is the do while loop. Till now we have covered while loop or the for loop. In while we can check the condition that will be executed. In for loop we can check the condition, initialization, increment, decrement in only one line. In do while loop it is used like this one. Do this one, this one, this one. Check the condition at the end. That is, once it is executed, one time it definitely executes, and at the end the condition will be checked. What is the condition? While the condition is true. It may be any condition. There is a minor difference between the working of the while and the do while loops. The difference is the place where the condition is tested. That is the place where the condition is tested. That is the main difference. What is the main difference? The while tests the condition before executing any of the statement within the while loop. That is, the while loop first of all tests the condition before execute any one of the statement that will be available within the while loop. But do while loop tests the condition after having execution of the one statement within the loop. That is, at one time the instructions are executed within the block, then only the condition will be checked. That is, do while checks the condition at the exit point, and while condition checks the condition at the entry point. So do while is also known as the exit control loop, and the while is known as the entry control loop. I am repeating again, while is known as entry control loop and the do while is known as exit control loop. Why? Because the condition is checked at the exit of the loop, that is exit control loop, and in while the condition is checked at the entry of the loop. That is why it is known as entry control loop. This is a figure. First of all start, then initialize, body of the loop, increment. Then check the condition, either it will false, either it will true. This is the example of do while loop. Print the hello there, then check the condition. So this will be printed at least once. This program, this says the printf will be executed once, since first the body of the loop is executed and then the condition is tested. There are some occasions when we want to execute a loop at least once, no matter what. This is illustrated in the following example. Now finish off the looping. Thank God. Till now we have covered while loop, for loop and the do while loop. So this is the summary of the chapter what we have covered. That is, the three types of loops are available: for, while, do while, break statement, continue, do while statement. These are the operators that will increment the operand by 1, while the minus minus decrements the operator by 1. Then these are the compound assignment operator that will use to modify the operand to the left of them. These are the various exercises on the basis of the while loop. This you have to solve, and if there is any doubt then please ask from me. Please perform these activities so that you can learn, or you will know where you are standing. That is, either you are understanding each and everything or not. So please try to do this thing. Now this is on the basis of for, break, continue, do while. This is the interesting question. The three parts of a for loop are: one is initialization, then test, then increment or decrement. These are the various questions that will be used. Now next is your case control structure that I will be starting in the Monday's class, that is 2 days or the 2 days later class. So let's stop over here only. In the Monday's class, I will be starting in your next chapter, that is the case control structure. Now, if you have any doubts regarding today's class, regarding previous classes, then please ask from me. So please ask from me. So that's all for today's session. Thank you so much, everyone.